The last day of class is the 30th of the month. That's 2 weeks from now. Okay, it's not Friday. It's not this Friday. It's next Friday. Okay, I sent y'all an academic calendar the first week of class so you could keep up with this. This class does not meet on Monday, Wednesday, and Friday. April the 30th is on a Friday. So that means that the last day this class will meet will be Thursday the 29th. Everybody with me? We will meet on Thursday the 29th. Now, my plans for this class is for Tuesday and Thursday of next week. Tuesday and Thursday of next week, I want to go over a little bit of antiderivatives. That will be on your final exam. Okay, antiderivatives will be on your final exam. I will cover them. And luckily, you only got 3 sections, so they don't really cover it a lot in 130, but I think you need it. I think you need it more than you do that other unit. I think you need antiderivatives more than you need the other unit. So, like I said, we're going to go over next Tuesday and Thursday. I'm going to go over antiderivatives, and it will be on the final exam, which will be on the last day of class, which will be that Thursday. Well, I'll give you like the weekend to do the final exam. Okay. 80% of your class will come, 80% of your grade will come from all unit tests. Y'all know that from the first week of class. 20% comes from your homework assignments. Let's say I gave y'all a test back in class. Let's say that everybody's sitting in conventional class, and I gave y'all a test back, and I accidentally gave everybody in the class 20 points extra. Is anybody going to raise their hand or send me an email that say they're confused that I gave them an extra 20 points?
No.
No, sir.
No, nobody's going to do that, right? So if you ever see anything on MyLabs Math and it could be to your advantage, what should you do?
Just let it be.
Take advantage of it. Let it be. Don't write me an email. I'm confused. Those people irritate the crap out of me. Okay? Please don't email me and say, I'm confused. So-and-so has this, and I thought we were to take advantage of it. If you know me, you know what I'm talking about. If you don't, then ask one of your fellow classmates that's had me before if you're confused, okay? Please do not act like a lone wolf with me, because at this time of year, this is when the lone wolves come out. Now, we've talked about this. The lone wolves, none of you are lone wolves because you come to class. Lone wolves don't come to class. They don't attend class. They don't watch the videos. They don't communicate with the instructor at all. All they do is they sit at home and they look at the syllabus. They read the book or do the problems in the book or MyLabs Math, and they come to me on May the 9th, which is after exams, and they ask me, I didn't understand. No, you didn't understand because you didn't attend class and you didn't watch the videos. So you choose to be a lone wolf. You face the consequences when you didn't take advantage of certain situations that the class took advantage of. All right. I have to say that because these people right here, there's usually 1 or 2 in every class. And they're the ones that cause the problems with teachers and administrators, because what they do is they don't communicate with the class or the teacher, and then they cry wolf when they didn't know something, and then they tell the department head or the dean, well, I didn't know that. Well, you didn't attend class. So anyway, I'm going to go ahead and tell you, if you're a lone wolf, you suck, which none of y'all are because y'all are in class. But any question? Oh, final exam. Final exam, 2 attempts. Takes the higher of the 2. You'll have probably the weekend of the 30th to take it. And it will cover all my unit tests. So if I've covered it and it's on your unit test, then it will be on the final exam. So anything I skip, which will be that 3rd unit, I skip the 3rd unit, then that will not be on the test. You'll have 2 attempts. It's a 2-hour exam. It's not 2 hours, but you have 2 hours to take it. Takes the higher of the 2. Calculus, I can't. Sometimes a calculus test exam will be shorter than a normal exam, math exam, because the calculus takes a little bit more time with all the algebra involved. Notice I said the calculus takes a little bit longer because of all the algebra that's involved. The only thing you've learned new is calculus. 90% of the test is going to be algebra. Okay. By the way, Hubert, you haven't assigned the chapter 4 skills check. Okay. I thought I did that. I'll look at it again. Thank you, and remind me at the end of class, and I'll check on that. I thought I did that the other day, but I guess I didn't. Okay, so again, the last day of class for this class is the 29th, the Thursday. That's the last time that we're meeting. Please do not write me an email or put a message on Teams that says, do we meet tomorrow? Meaning Friday. No, you don't. You haven't met Friday in this class the whole semester. Why in the hell are you going to meet the last day of class on Friday? Okay? The last day of class for this class is Thursday the 29th. Okay? Make sure you get, make sure you've gotten all your unit tests done, because the unit test and the final exam will count 80%. Make sure you got all your homework done. That counts 20%. And make sure that your final exam is done by the due date. Whenever I put it on there, I can't. Have I already assigned the final exam? I don't think I have. But
I think you've assigned all the rest of the stuff that we have to do.
I saw the final exam on there last night.
Okay, don't touch it yet. I mean, somebody's going to, so I might as well forget saying that. But I might have to make some adjustments on the final exam according to, I think I will get to the antiderivative, so I'm not worried about that, because that will be on there. But
can we go ahead and do the Unit 2 test, Hubert, or no?
Yeah, you can if you want to. I'm going to go over questions today.
Okay.
I'm going to go over 2.6 questions, because those are the most difficult questions.
Okay.
And please don't take the final exam until I finish the dadgum antiderivatives. You shouldn't even be thinking about the final exam, okay? But I put it up there because I went through all my classes and I did some tweaking and did some putting on this and putting on that, so that way people could work on certain things when they want to. All right. We're getting toward the last of the semester, so I'm trying to loosen up everything in my class so y'all don't run around like a chicken with your head cut off as far as my class goes. All right. Who's got another question? Does anybody have any questions? Hopefully, having this stuff open will kind of leave y'all with, okay, I don't have to worry about this because it's due on this day. And that way, you're not sending me a bunch of emails acting like the world's ending, because I know y'all do that. Any other questions? 2 hours to take the final exam. It won't take that long. And I can't remember how many's on it. We'll look at that Thursday of next week, okay? We'll look at it and see. 2 attempts, takes the higher of the 2. It'd probably be due Monday, I think. Somebody look at the final exam. When is it due? Anybody see it? And
May
the
3rd.
when?
You have the due dates
May
for
3rd.
everything May 3rd, Hubert.
Oh my gosh. I have the due date for everything on May the 3rd. Wow.
Why did y'all
There's-
say something?
Well, go ahead, Mr. Palmer. What?
I said, why did y'all say something?
Don't
just-
worry.
We
There's
just
some.
talked
There's
about this.
one
All right.
student in here. There's one student going. So don't worry. Somebody will screw it up. All right. So I think that's done. And let's get to the homework questions that I've received. I'm going to go through the 2.6 first because I think that is the hardest, more complicated for a lot of you. And also, it's the last one we went over. So I'm going to go over those first. So here we go. 2.6, 54/20. 2.6, 54/20. And I'll probably go over the exam. We'll probably go over the exam a little bit this Thursday. The not the final exam, but Unit 2, this Chapter 2 unit. I'll probably look at some of those questions Thursday. All right, so this one says, and this is not a test question, number 20. The reason is these questions, right? Well, this one might be because it's kind of a plug and chug question, okay? But I don't do a lot of these questions on the test because, like I say, after maybe a couple of biology classes, yeah. But, you know, if I was teaching a second or third calculus, yeah, I would put a lot of these on the test. But, you know, this one's a plug and chug, so it's not a big deal. So your initial, your formula for the intensity of sound is I is equal to, and I'm going to show the whiteboard in just a minute. Your initial intensity times 10 raised to the 0.1 times L, which is the decibels. Okay, I'm going to let y'all write that down. And then just write down for A, you're going to plug in 80. Write down for B, you're going to plug in 30. C, you're going to compare those two. D, take the derivative. And then E, what does the derivative mean? So take a second and write those down. Out of all the, you know, quirky word problems in 2.6, this is probably the only one I would put on the test. Because there's one homework question, I don't even know why it's in your homework. And that's 2.6. I can't remember. I put yuck beside it because it's a terrible problem. Can't remember where it is now. It's in here somewhere, but some of these problems are dang ridiculous. All right, so A, I'm going to plug in 80. B, I'm going to plug in 30. C, compare. D, find the derivative. All right, so here we go. So here I'm going to do I is equal to I sub O, 10.1 times 80. And 10% of 80 is 8. So that's equal I sub O, 10 to the 8th power. Same here. I is equal to I sub O, 10.1 times 30, which is equal to I sub O, 10 to the third power. Just plug and chug. Now, compare A to B. Well, that would be 10 to the 8th over 10 to the 3rd, which is equal to 10 to the 5th. So the lawnmower or whatever it said is much louder, 5 times louder than whatever the sound in B is. The derivative, you're going to take the derivative of this guy, and the derivative basically is going to be 10, let's see, this guy right here. So that's going to be 10 to the 0.1 times L times the natural log of 10, or the natural log of 10 times 10 to the 0.1 L. And anytime they ask you for what is the derivative, interpret the derivative, rate of what? Rate of change. Remember, the derivative is a fancy slope, and slope is equal to rate of change. So whenever they ask you to interpret the derivative of something, always remember it's the slope, but slope equals rate of change. And that's based on the loudness of something, based on how loud something is. Now, the only reason I would put this on the test, if I did, is because it's pretty much plug, chug, find the derivative, and what is the derivative? It's the rate of change based on how loud something is. So go back to the handy dandy. So the first one, we'd type that in. That would be I sub O, and that would be 10. Let me type that in. 10, shift up to the 8th power. 10, shift up to the 3rd power. 5 times as loud. And this one is natural log of, what is it? Natural log of 10. Natural log of 10 times 10 to the 0.1 L, 10 to the 0.1 L. I'm thinking we might want to take the derivative of 0.1 L. That's supposed to be a capital L. Capital L. Might need a 0.1 in there. Yeah. I think you're going to need a 0.1 times 0.1. Of course, I don't have it written the way they want it written, times 0.1. Because the derivative of 0.1 L is 0.1. But I don't have it written in the right order. There it is. Okay. And the rate of change based on its loudness. So bravo. And please make a note, that's not a smudge on your screen. That is a 0.1. The derivative of 0.1 L is 0.1. If this was 0.2 L, there'd be a 0.2 out here. If that's a 5 L, there would be a 5 out here. Because you got to remember, that's parentheses And you got to remember the chain rule. You always have to multiply by what's inside. Any questions on that one? And I think that's fair giving you that question versus the other questions, because some of these questions out of 2.6, they really suck. So this next one is 2.6, 51/19. 51/19. This one is kind of like the one we just did, only it's a different problem. In 2012, 34.1% of all glass containers were recycled. On Bar Rescue last night, they had a bar owner that has a basement under the bar, and he had these PVC pipes running to the basement, and one was for cans at the bar and one was for bottles, and they just dropped them down there and it went through the floor. That was cool. I mean, that was some pretty smart thinking. I have no idea why. Oh, and when they hit the cement floor in the bin for the bottles, of course they would shatter until it got, where it wouldn't shatter because it was landing on glass. But he would take a hammer down there and beat it, and he would take that glass and take it to be recycled. I thought that was pretty cool. Oh, no, shut up. All right, nobody's going to say anything. In 2012, 34.1% of all glass containers were recycled. A beverage company used 150,000 pounds of glass containers per year. After recycling the amount of glass in pounds still in use after 2 years is given by this formula. That's N of T, so 2.6, 51/19. And basically N of lowercase t is equal to 150,000 times 3.321 to the t power. And it says, and I'm going to write everything down. A says N of 5. B says N prime of 5. And C says, when will 9% be used? Okay, so we've got 3 questions to do. And there is our formula. And first of all, we're going to take A, we're going to plug in 5. So everybody should be able to do that. So N of 5 is equal to 150,000 0.321 to the 5th power. Now somebody do that for me in your calculator and tell me what you get.
I got 511.23.
511.23. So that means 511.23 pounds after 5 years. Okay. Did everybody get 511.23? Okay, now nobody's going to say anything, but B, I want somebody to find the derivative of this function. Now, you don't have to worry about the 150 because that's like a constant. you need to take the derivative of 0.321. That's something to the x power. So you're taking the derivative of a variable in the exponent. So go ahead and take the derivative of that function and plug in 5. I'm going to let y'all do it on your own, and then we'll do it together. So take that function of 150,000 times 0.321 t power and take the derivative of it. That dadgum Dogecoin ain't gone up 1 penny. Sucks. All right. So we've got the derivative of this guy right here is what we're going to take the derivative of. So that's going to be n prime of t is going to be 150,000 times, well, the derivative of something to the x power is equal to the natural log of the base times the actual function, 0.321 to the t power. So there is, and you can multiply that natural log of 0.321 times 15,000 if you want to, because those are two numbers. You could actually do that. And then plug in n prime of 5 is equal to 150,000 times the natural log of 0.321 times 0.321 raised to the 5th power. Now, when you plug all that in, I got negative 580.92. So after 5 years, the amount of glass still in use is changing by 580. It looks like it's decreasing of 580.92 pounds per year. Okay, so that's A and B. Nobody's got any questions or anything? Okay.
No, sir, I think we're good.
Okay. Now, C. What are you going to do with C? It says 9% can be used, or 9%. You got to take 9% of the original, I think it said 150,000 in the question. So before we start C, you've got to actually take 9% of the original, amount. So C, we've got, for number 1, we've got to take 9% of original amount for n of t. So that would be 9%, 0.09 times 150,000. because that 150,000 was in the original question. So if you look back at the question, a beverage company used 150,000 pounds of glass. So we have to actually use that 150,000 here. Excuse me, starting the yawning thing again. So 0.09 times 150,000 is 13,500. And that's equal N of T. So you're going to take that and plug it back into the equation that we have, and that's going to be 13,500 is equal to, and that's going to be 150,000 0.321 to the T power. Excuse me. Now divide by 150. And 0.321 T is equal to, and I got 0.09. Somebody check me. And I want y'all to take the log of both sides and finish it out, please. Somebody check 13.5 minus 150. What do you get? Okay, I guess.
Yeah, that's right.
Sorry. 0.09, is that what you got?
Yes, sir.
All right, now take the natural log of both sides and finish solving it. Give you about 30, 45 seconds to do that. So take the natural log of 0.09, natural log of 0.321 to the T power, and pull that T out front using the power rule. Natural log of 0.09 equals T times natural log of 0.321, and T is equal to the natural log of 0.09 divided by the natural log of 0.321. And when you do that, I got 2.12. So 2.12 years.
Yeah, that's what I got.
Okay, the only reason I like this question is kind of like the first question is pretty much self-explanatory. Plug and chug, find the derivative. Those questions I don't mind, as long as they're not too time consuming. The next question is a 100% test question. You'll see why as soon as you see it. Okay, and that is 2.6 35/17. 2.6 35/17. And look at it. Why is this one a test question no matter what? Why is this one a guaranteed test question?
Those are the type of problems we've been doing.
These are the type problems that I drill and drill and drill you on, because this is the mechanics of derivatives. You got to learn the mechanics before you can learn how to be fancy with them, like with the word problems. You got to learn the mechanics. This is your basic product rule, and it's your basic exponential derivative. So do it. Product rule first times the derivative of the second, plus the second times the derivative of the first. So go ahead and take about 30, 45 seconds, set that up, and we'll do it together. Dogecoin is pissing me off. I know what they're doing. They're trying to get people to sell quick so they can have more to buy. That's what they're doing. Not me. I'm not selling them.
What are you going to sell out, Hubert?
I want to see what it's going to do in the next few weeks. I don't know what it's going to do. I mean, well, first of all, I would get my initial investment back. As soon as I get above a good bit and at least 20, 25, maybe 30%, then I'll get my investment back. And then that'll be whatever's left is just nothing but profit. So I always do that first. So, but right now I'm just I guess I'm just trying to see what's going to happen. My personal opinion is everybody else is doing the same thing I'm doing. They're waiting to see what's going to happen. And since it didn't jump up to 60 cents today, everybody's being kind of cautious. So I guess that's what I'm going to do. But yeah, I always, whenever I do stock trading, I always get my investment back first. Kind of like when you play the lottery, as long as you get your investment back, you haven't lost anything. Capiche? If you walk into Vegas with $2,000 and you leave with $2,000, have you lost anything?
I'd say that's a win in Vegas.
Yeah, if you walk in to Vegas into a casino with $2,000 and you leave with $2,000, you haven't lost a thing. Now you could have another pocket full of money, or you could not have any money, but you still got your $2,000. You haven't lost anything. All right, so here we go. X to the 7th times 6.3 to the x power. So first, I'm sorry. First, times the derivative of the second plus the second times the derivative of the first. So that's going to be x to the 7th times. Now, we've got the natural log of 6.3 times 6.3 to the x power. I'm going to do that in orange. So natural log of 6.3 times 6.3 to the x power. That is the derivative of 6.3 to the x. Plus 6.3 to the x times 7x to the 6th power. And now it's just a matter of you condensing it, or I don't really see anything you can do. You can't factor, you could factor out 6.3 to the x power and an x to the 6th. You could factor that out, but there's no use in it. So I would say probably the answer is this. I'm going to go ahead and factor it out just to let you see it. Or 6.3 to the x times x to the 6th. And that's going to leave x times the natural log of 6.3 plus, what, 7? So that is 2 possible answers. I doubt very seriously that they would take factored out. So I'm not going to type all that in. I'm just going to type in a 3, and then we can check your answer. All right, x to the 7th. Check our answer. X to the 7th times the natural log of 6.3 times 6.3 to the x plus 6.3 to the x times 7x to the 6th. We are smart. We feel good about ourselves. So we don't have to drive a truck that looks like a dog scraping his blood across the carpet. That's something y'all gonna have to explain to me. I can understand trucks being ground effects. I can understand trucks being uplifted. I can understand trucks being customized. But I cannot understand a truck squatting on the back end. That is the dumbest thing I think I've ever seen. I'm sorry. I want somebody to try to explain that to me. Anybody?
I can tell you exactly why they do that.
What is it? What? Tell me why people do that.
Because Mama and Daddy paid for that truck, not them.
I'm sorry. I didn't hear you. What?
Mama and Daddy paid for that truck, not them.
Oh.
That's exactly.
Well, I was trying to find out the meaning. Okay. No matter who paid for it, and I understand what you're saying. But what's the meaning of it?
They think it's cool now. I mean, all it does, it'll destroy your engine in a heartbeat. I mean, I don't understand it whatsoever either.
It makes no sense to me. I mean, I can understand the ground effects. Ground effects makes a car look cool. I understand that. I understand four-wheel drive being jacked up, too much. You're either bald or you're short or you got insecurities. But, I can understand fixing a 69 Camaro. I can understand, I can understand all those. But I cannot for the life of me understand a truck squatted in the back. That makes no sense whatsoever. And if somebody could explain that to me, I would appreciate it, because I just can't understand it. My son can't explain it. He says it's the dumbest thing he's ever seen too. So I don't understand it. 2.6, 33/16. 2.6, 33/16. Somebody tell me if this is a test question or not. It's coming up. Hold on. Yes or no?
Yes.
Yep. Ding. That is a test question. So just do it. Give you 30, 45 seconds to get it started.
Yeah, Hubert, the trucks being squatted, I think they make the town look bad.
I don't understand it.
They look really bad.
And my son says you got to dress a certain way to drive a truck like that. You got to have your hair like in a mullet or long in the back, and you got to wear your cap a certain way. And I'm like, really? So maybe y'all can. He calls them yee-yees. I don't know what a yee-yee is. Never heard of that before. Maybe I'm just out of touch. Back in my high school days, you'd call that person a dumbass. Because you could get the same effect by putting a bunch of cement blocks in the back of the truck, you know, where nobody could see them, and you wouldn't have to pay anything. First, I'm just going to go ahead and set it up. First times the derivative of the second log base 5 of x plus the second times the derivative of the first. All right, so this is what she looks like. So I'm going to give y'all a couple more seconds to finish it out. First times the derivative of the second plus the second times the derivative of the first. Now here you're taking the log change base formula basically, which is 1 over the natural log of 5 times 1 over what? X. And here you take the natural log of 9 multiplied by 9 to the x power. Now there is one thing you can do to simplify. Can anybody tell me what that is? You can maybe do one more step to simplify. Can somebody tell me what that step is? That means y'all gonna have to communicate.
You could put the x in front of the fraction, right? The natural log.
The what? Okay. Yeah, but there's one more step right there you could do too. He's talking about right in here, put the x in front of the natural log, yes. But what else can you do in this step right here? Come on. There's not really anything you can do out here. This is pretty much, that's it. But what can you do here besides put the x in front of the natural log? What else can you do? Thank you, Miss Holcomb. So y prime is equal to 9 to the x power over x natural log of 5 plus all this. So you put the 9x maybe out in front if you wanted to. 9 to the x log 5x natural log of 9. I don't know. Let's see what their answer is. I don't know. They might have just done this. They might have not even put the 9x there. I don't know. Let's see what their answer is. They did put the 9x on top. Okay. But as you can tell, the rest of the 3 terms here, there's not really anything you can do with these 3 terms. I like that problem. As far as a 2.6 problem. And this is the problem that sucks. Okay. And the reason I say that is because this problem, they're assuming a little bit more than what you would do in a regular first variable statistics course. First of all, the question is confusing. It says find an exponential function of the form p blah, blah, blah that models the situation, and then find an equivalent exponential model of the form. What does this problem say to you when you see it? Be truthful. I'll do this one last. If you had this on a test, what would you do or say when you came to this problem? Okay, forget it. I'll just say it. I would skip it and come to it when, if I had time. All right. So this is not a test question, but I thought I would show you how to work your way through it. And when I say work your way through it, I'm talking about like working your way through a barbed wire fence. Okay, because this one is probably the worst question that you could put in this homework. Okay, it's not a favorite of mine. All right, so first of all, what do they give us? Well, they give us P of T, and this is 2.63/7. And I'm writing down. I'll show the whiteboard in just a minute. All right, they give us the initial equation. P of T is equal to the initial P.
Is this a test question, Hubert?
No, hell no.
Okay, good.
This would never be a test question on my test. Okay, y'all remember PERT, right? Well, that's what you're comparing it to. P of T is equal to PERT, P e to the RT. And they want you to initially get this one to look like that one, and tripling time of months. So that means P of O in this question is equal to 5,000. N is equal to 3 because you're multiplying it by 3 because it's tripling. And then T, big T, not little t, is equal to 6 months. So this is what they give you. They want you to get this to look like PERT, which is just about the same. It's in the same form, P-E to the N-T power. Okay, RT power, sorry. So the RT, it's NT, sorry. Wait, no, it's RT. Okay, so this is P-E to the, or P-N to the T over big T power. So it looks kind of like this, but they want you to end up making this look like this. And they give you this information right here. So the first thing you want to do is maybe plug and chug into this right here. Okay, so that's going to be, so I'm going to go down here or go here, and that's going to give me 5,000. So P of T or P of 5,000 or whatever is equal to 5,000. That's my initial. And N is going to be 3. And T over 7, I think. Didn't it say 7 months? Yeah. T is equal to 7, not 6. Sorry. Yeah. So T over 7. Okay, now that's the first thing you want to do is you want to plug that in. Now, this is the part I don't like. Then I'm going to put it in red because you're just supposed to know this. Note, approximate T over 7 as 1 over 7. Okay, so I don't know where that comes from, but that's what you're supposed to be able to do. I assume maybe like the derivative of 1/7 T is 1/7. I think that's where they're getting this from, but I never could find out where let's see, the derivative of y is equal to 1/7 T. Y prime is equal to 1/7. That's where I'm getting it from. So I want you to make a note of this because this is kind of the part that I'm not aware of, and I'll just be honest with you. And that's where I came up with the 1/7 as taking the derivative of 1/7 T, which is this right here. And that's where I'm getting the assuming 1/7. So I can rewrite this as P of T, equal to 5,003 to the 1/7 power. Okay. But what I'm going to do is I'm going to take the natural log of 3 because if you write let's see if I can, because this is very confusing. They want us to take, where is my pen? They want us to take basically this, and they want us to make it look like that. So we could actually take N and make it into e to the natural log of N. So, because that's an E right there. So if we take N and we change N to, or E to E natural log of N, and plug that into the formula right here, I'm sorry, to the T over T power, and we've got 1/7, then we can actually use the power rule to say e to the natural log of 3 to the 1/7 power. And we can distribute that and get, using the power rule, and natural log of 3 times 1/7. This is a lot of assuming here. Okay, so I'm going to do e to the 1/7 times the natural log of 3. So take natural log of 3 and multiply it by 1/7. So take your calculator and take the natural log of 3. Natural log of 3 times 1 divided by 7. 0.1569. So that's equal to 0.1569. Now I can rewrite, therefore, like I said, this sucks. Therefore, I can rewrite my P of T is equal to 5,000 e to the 0.1569 t. And that's what they're wanting you to do. They don't want you to plug and chug anything. I think that's all they want. Let's see what they want as far as the answer. P of T is equal to 5,000 E. Where is it? I'll just type in E. Shift up 0.1569 T and pray. See, I've got it wrong. That's what I got. I don't know what they want. We'll see what they're wanting. Okay, they didn't, they left it as 3 to the 1 to the 3. Oh, wait a minute. Let's see if they asked for it. Okay, here it is. 5,000 e to the 0.1569. There's the answer. Not a very good problem. But I showed you how to do it so you can muddle your way through it as far as the homework goes. But the reason they're getting that 1/7 is because I think they're assuming taking the derivative of t over 7, and that's where they're changing that from a t over 7 to a 1/7, and that's where they're getting the 0.1569 from. All right, let's move on to another test question. 2.629. This is a test question. Now this one I'll put on a test to try to see if you know what you're doing. So I'm going to let you, this was our last one today because some of y'all are going to start convulsing. So write this one down. G of x, this is 2.6 29/14. And it says g of x is equal to log base 29 7x minus 2. Now, somebody tell me why I put pink parentheses around that 7x minus 2. Just tell me what rule applies that I would put that pink parentheses around that 7x minus 2.
Is it the product rule?
Nope.
Algebra.
Chain rule. Miss Holcomb is correct. Miss Holcomb said the chain rule. She is correct. That's the part that most of you as students would leave out of the answer. This is what students would do. Okay, that's log base 29, so I used the change base. So that's going to be g prime of x is equal to 1 over the natural log of 29 times 1 over, and then put 7x minus 2. And that's what students will do, and they'll get it wrong. Why? Because they not only have to do 1 over 7x minus 2, they have to take the derivative what? Of what's in the parentheses. And what's the derivative of 7x minus 2?
7.
And that's the part you'll leave out. So your final answer is g prime of x is equal to 7 over 7x minus 2 times the natural log of 29. Now, the reason I like this question is it does kind of challenge you a little bit on your knowledge of the chain rule, and it also is short and sweet. That's the kind of questions I'd like to give you. All right, let's finish this one up. I'm going to hit 3, and let's see if they wrote it the same way I did. I put the 7x minus 2 in front of the natural log. That's what most people do, but the same answer. Okay, so I got these out of the way. Delete, 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 delete. Okay, so we are going to go over the test Thursday. So make sure you're here Thursday. And we're going to, like I say, finish homework questions. We're going to go over the test first. And then we're going to go over any homework questions that I can need to go over. Okay? So with that being said, I'm going to go over the roll right quick. And, well, Tri-County just logged me out. Hold on a second. Got to take care of some brick phone business.
So should we be just reviewing for the test?
Thursday, we'll review for the test.
Okay.
And we will do homework questions. Then Monday and Thursday of next week, I will go over antiderivatives, which will be on your final exam. And 1:30, set attendance.
So
and
do we
after I
have test from now to the final exam,
I'm sorry, what?
do we have another test in between now and the final?
Okay, I thought I went over this. We will have the test open up Thursday, and that will be the unit or chapter 2 test. Then I will cover Tuesday and Thursday of next week. I will cover antiderivatives, and that will be on your final exam.
Gotcha.
Okay. All right. So, okay, Miss Holcomb's here. All right. Abdallah is here. I think I saw him a while ago. Abdallah is here. Yeah. Abdallah, Abrams, Armstrong, and y'all can leave as I call out your names. Babineau is here. Bagwell is here. Berry is here. Cobb is here. Let me move up. Cox is here. Holcomb is here. Hollister is here. Ingram is here. Jarkowski is here. Kelly is not here. Krieger is not here. Lawrence is, or Ladowick is here, sorry. Both Melnicks are here. Moman is here. Morris is here. Okay. Neiniger is here. Neiniger is here. Odom is here. Palma is here. Ridings is here. Schmidt is here. I don't see Shaheen. Shaheen is not here. Taylor is here. Wiggins is here. And Wood is here. Okay, let me finish this up. And of course, y'all can hang around. Just make sure those people that leave your computer and, go back to bed.